Hello, everyone. So today we're on lecture number 17, and we're continuing with our 5-step process with our 4th step, which is the result step. Now, this is the longest step. It takes the most calculations in most writing. So it's also the most difficult step since it is the longest one. And so we're just going to look at this one step today. So I'm going to share my screen so we can pull up the notes for today's lecture. So here we have lecture 17 notes, and I'm just going to talk about the result step. So the result step is what we're going to do is we're going to take some calculations to find out where the sample is in comparison to my curve. So if you think about it, the curve is centered at my null hypothesis, that's my H naught, and I'm going to find out where does my sample compare to that center. So we have some visuals we'll look at too in a little bit, but I wanted just to, that's what we're going to do, take a look at the location and the meaning of that, and then we're going to calculate that probability in the tail. So you know how we find the probabilities of the area, or we find the area under the curve. That's what we're going to do, and we're just going to find it in the tail. So it might be in the left side or the right side, or it could be both sides together. So I'm going to keep scrolling down here. We can take a look. So the result step we have for both numerical and categorical sets separate. So because what I need to do and calculate and what I'm looking at depends on the type of data, and it changes for the different types. So first we're going to look at, for means, the numerical data. We're going to get the t-test statistic. So that's my t-value. So we calculated the t-value before. It's the same way as calculating like a z-score. So we can see here it's the same calculation, except for it's what I'm plugging in. So what I'm plugging in here is my data value, which is x bar, because I have my sample mean from my sample, minus mu naught. Now, mu naught is the center of my curve. It's my hypothesis for my null, divided by the standard error. So I took the calculation over one more time to the right just to break down what the standard error is. It's S divided by square root of n. That's my standard deviation of my sample divided by the square root of my sample size. What this value tells me, this is how many standard errors our sample is away from the center. So it gives me a location for my data, okay? Right from here, we could start looking at a curve if we wanted to, okay? Sometimes it helps a lot to draw it out, because then it helps us calculate the probabilities, just so you know. We're going to interpret this test statistic. So the way we interpret it is just saying our sample mean is whatever our test statistic value is, and I have an absolute value, standard errors above or below, I don't know why this is here, above or below my center, mu naught. So my sample mean is, maybe if I have 2.5 standard errors, and if it was positive, above my center. Or if it was negative, it would say below the center. Instead of just saying the center, I'm actually going to put in the value from my null hypothesis there. That's the center of my curve. So that's a quick one. You can even abbreviate. Sometimes I get really quick with this, and I might say our x bar is 2.5 SEs above or below, whatever one, above 0.67 or whatever it is, okay? So if you want to shorten it right up like that with abbreviations, I'm completely fine with it. It's just telling me that you understand what that t-value means. Now I have a p-value. This is new for us, a p-value. P-value just represents the probability, okay? So it's the area under the curve. We're going to calculate this p-value using what we've done before for like our normal curve, our standard normal curve, everything we've done before. So the probability, we're looking at another t-value would be either less than or greater than the t-test statistic that we got in our sample, okay? So, excuse me, it's the probability under the curve depending on where my value is located, if it's less than or greater than. It goes with, sorry, I'm like choking on my own saliva. The less than or greater than corresponds directly with where my test statistic is located, if it's above or below. So greater than would mean it's above my center. Less than would mean that it's below the center. or you could look at it and it goes directly with your HA. The only scenarios when it doesn't go with the HA is when the HA is a not equals. Then you would look at your test statistic, and is your test statistic above or below your center? And then you know it goes with it, okay? From the problem, you should be able to just get it from the reading if it's greater than or less than, right? We'll look at that in an example. And to calculate that probability, I have a new thing right here, TCDF. So before, when we're looking at the Z curve or just the normal curve, we would say it was normal CDF, right? This is TCDF. So it's saying I'm going to use the T curve and I'm going to calculate this area. So just like before, it's lower bound and upper bound. And then here I put in degrees of freedom. Remember what degrees of freedom are? It's n-1. So in this case, oh, I don't have an example. But so if n was like 50, then n-1 would be 49. And you would plug that in there. So we're going to find this in our calculators in the same location as we have our normal CDF. So when you turn your calculator on, you go to stat, no, you don't. You go to second VARS, which is distribution. And on my TI-84 Plus, it is option number 6, TCDF. Okay. I always encourage you guys to draw a picture. If it helps you, it helps most people. It helps me sometimes, okay? It's nice to get that visual. Now I need to interpret this p-value. I need to interpret what the probability means to me. This is tricky, okay? So it takes a little getting used to. I give you these templates. You may use the template and just plug values in, or you may put it in your own words. So what the p-value interpretation is saying, that if the population mean equals my null hypothesis, so I would plug that value in here. So if it is a certain value, so saying the center of my curve is the null, which is that common view, there is a p-value probability. So again, I'm going to take my calculation number and I'm going to plug it right in here. So it might say like 0.025 probability of getting another sample mean at least as extreme as the one we got from sampling. So what this is saying is that that probability I'm calculating is telling me that's the probability of getting another sample that far from the center as I did from the original sample I took. Okay, so sometimes it's just a hard concept to wrap our head around. The probability is telling me that that's the probability of getting another sample, like a second, third, or fourth sample, and that value will be that far away from the center as my original sample is telling me. Okay, so that's what that's telling me. We're going to do those, the second and fourth steps, the interpretations on both numerical and categorical, and they're basically the same. It's just my calculations differ for the first and third part. So let's take a look at the categorical, so proportions. Remember, we're on the Z curve here, so we're looking at the Z test statistic. I'm going to calculate this. Same calculation as the T, except for now I'm using my proportions, right? So I'll use P hat. P naught still represents my null. My standard error is in the denominator. So my standard error calculation is different, right? Here it is. I'm using P naught, right? In that calculation. That's the number from my null. That's how I check my normality, because that's the curve I'm on. Again, this represents the number of standard errors that our sample is from the center of the curve. All right. Here's my interpretation. Our sample proportion, or our p hat, is whatever that test statistic value is, standard errors above or below the center. Same exact thing. Again, my p-value, I'm going to calculate the probability, the area in the tail, the area under the curve, and we just call that a p-value. So here is my setup. So the probability that another z-value is going to be less than or greater than the original one we got. So here now, since we're back on the normal curve, it's going to be a normal CDF. I do lower bound, upper bound. Look at what I'm looking at, Z's. Z, the Z curve has a center at 0, spread of 1, right? So I plug in 0 and 1 here. Again, draw a picture if it helps you out. And then my p-value interpretation is exactly the same. So let's take a look. Oh, my screen. Oh, there it is. It was freezing on me for a minute. So let's look at some of these graphs. So first of all, I'm just showing you some graphs with alpha. So remember, alpha is my level of significance. We're going to use this in the conclusion step, which is my very last step. We're going to learn that next lecture. So, but I wanted to show you what it looks like. So here's what we call a right tail test. So that means my test statistic would be somewhere over here. I don't know if it's going to be to the left or to the right of the critical value. That's something we will find out in the conclusion. But what I'm trying to show you is the curve and where alpha is located. So on the right tail test, that means it's a greater than. I'm looking at an alpha over here in the tail. Okay. And the left tail is over to the left. Again, my alpha is in this tail. Since it's left tail, it's on the left. It means I'm looking at a less than. Or I have the two-tailed test. Now this one, it's really the same. Everything we're going to do the same. It's just now it's split between two. So I don't have alpha in each tail. I have alpha between the two tails. So when I add them up, they should add up to alpha, my level of significance. So what that means is that they're each alpha divided by 2. So this is like a center. You know, similar to like the CI, right? The CI is a center. We don't have to calculate like this critical value. It's just the number, it's just the test statistic that corresponds with that area in the tail, the alpha. And we don't need to calculate the value because we already know what alpha is. It's just a visual here. Okay, so let's take a look now at some pictures with alpha and the p-value. Now that we know what a p-value is my probability, right? Here I'm showing you a t-curve. So the t-test statistic is shown here with a t and an asterisk. So I wanted to show you, right here's my curve, here's my p-value, my probability. It's like this light bluish green color. And here's my test statistic representing that. So my test statistic goes here on my curve, and then everything to the right of it, so this means it's a greater than, everything to the right is my probability. That's the value I'm going to calculate. Now, when I look over here, I'm going to add the alpha to it. We have two scenarios. The alpha can be smaller. So like if our alpha is 0.05, it could be smaller than my p-value, right? And we could see that visually here. Or it could be larger than my p-value. Something like this, okay? And it just depends on the problem. It depends on our sample. It depends on all of the information. So it's not like a right or wrong thing. It's just this is part of the testing process. Okay, so I like to give you that visual. Okay, and next class we're going to look at the meaning behind alpha being larger or smaller than our p-value, and how to make some sort of conclusion about this problem. And pull it all together. All right, so for our examples here, I just took the same examples that we looked at last lecture and I added on to them. So the first example is a percentage of students at RIT that approve of the university's administration. We want to prove that it's, or not prove, but we want to show support that it could be more than 67%. So we started and we did the first 3 steps, and now I'm going to add in the 4th step, and I did put a visual here for you so you can get an idea. So here's my curve, and now these are the calculations we're going to find right now. So here I have my z-test statistic I need to calculate. So I'm looking at my p-hat, which is 0.775, already found that above, minus my p-naught, this is my value from my null hypothesis right here, 0.67, divided by the standard error, which I use the 0.67 in my standard error calculation with n, which is 80, I'm sorry. Calculate that out. I find my z-test statistic to be 1.9973. So you'll see that this value is placed on our curve. It's positive, meaning it's above 0, so it's to the right, and it's 1.99. It just cuts off at 7. It rounded. But I want you to notice my HA is greater than, so I knew it should already be to the right. Okay, so that just kind of confirms I'm on the right path. I'm going to say our sample proportion is 1.9973. Standard error is above 0.67. That's all I'm talking about. Okay, I'm going to calculate the probabilities. I'm going to use the normal CDF. This is where the graph and this visual comes in, right? My normal CDF. I need to put in my lower bound and upper bound. So this is where a curve, looking at it, helps me out. So my lower bound is the 1.997. My upper bound is 10,000 or 10 to the power of 10. Some really large number. Then I'm going to use 0 and 1 because I'm on the Z curve. Okay. I'm going to plug that in my calculator. I'm going to find the area right here, this like little burgundy-ish red color. It's 0.0229. That is my probability. That is my p-value. I should put that right in here. I'm going to say p-value equals, there it is. If the population proportion is 0.67, so if that's the center, there is a 0.0229 probability of getting another sample proportion at least as extreme as the one we got from our original sample. Okay, so this is just the probability of getting another sample this far away, out this far. That's what we're calculating. Okay, let's take a look at this for the second example. So this is the weight of the apples. So this is numerical data. Again, I already have the first 3 steps. I'm going to just look at the 4th step. The same idea here. I'm going to calculate my t-test statistic. So I have my x bar, which we found right here above, 5.6. I think it was given. Minus 6, which is my value from my null, right here, 6. Divided by my standard error. So my standard error is S, which is 0.1, divided by the square root of N, which is 61. I'm just going to plug all these in, and you're going to see how I carried over. Now, I get a t-test statistic of negative 31.24. So when something says negative 31, that's really far from 0. If you think about, like, picture the empirical rule. You're normally like 3 standard deviations away, and you think you're far. 31 is really far, okay? So when I have 31 is really far, I'm thinking, okay, my probability, my p-value is going to be a small value. It's not going to be a large probability. And when it's negative, it's over here to the left. That means that my HA should be a less than, and it is. It just kind of all works together. It just kind of helps you confirm that you've done other steps in the right way, or maybe your calculations the right way. Let's calculate the p-value. I'm going to type that in here. P-value equals, it's the probability of a t is less than the negative 31.24. I'm going to use TCDF for my calculator. This is where the visual helps. It's negative 10,000 all the way up to negative 31.24 with my degrees of freedom here. That's n minus 1. So n was 60. Or I'm sorry, 61, so n minus 1 will be 60. I'm going to get this value and it looks like 0. It's not really 0. It's just my calculator is rounding. It looks like this. I want you to understand a p-value will never be 0. That's saying you have a 0 chance of it happening. It can happen. It's just a very, very small probability. It's a very small chance of it happening. So we never say a p-value is 0. If it looks like 0, we just say it's very small. Okay, so here I'm going to interpret that. So if my population mean is 6, so if the center of my curve is 6, there's a very small probability of getting another sample mean, at least as extreme as the one we got from sampling originally. Okay, so that's my result step. So let me know if you have any questions. I will be available on Monday at 12:30 in the Zoom chat. All right, thank you.